All right, so for number 21, we're going to consult the following table of data. And we have a combustion reaction of propane. And for the reactants, we have the H of formation in kjoules per mole and the S of formation in terms of joules per mole Kelvin. First thing we need to do is calculate delta G standard state for the reaction, and our way of doing this is we're going to have to use the relationship that the delta G of the reaction is the linear combination of the delta H of the reaction minus T delta S. So looking at our thermodynamic data, the delta H of the reaction is going to be equal to the H of formation of the products. So we have 3 times minus 394 plus 4 times minus 286 minus 104 minus 0. So the rest of this is just estimating work. So if we put this into our calculator, 3 times minus 394 plus 4 times minus 286 plus 104, we're going to get a value of minus 2222 kjoules per mole. We're going to do the same thing with the entropy of formation. So we will have 3 times 214 plus 4 times 70 minus 270 minus 5 times 205. Of course, we know already that this is going to be negative because we're going from 6 moles of gas to 3 moles of gas. And of course, we're going to verify that in a minute once we compute this. 3 times 214 plus 280 minus 270 minus 5 times 205. So that's minus 373 joule per mole Kelvin. I'm going to go ahead and convert this to kjoules. That's minus 0.373 kjoules per mole Kelvin. Okay, so I'm going to take these last two results and string them together and simply insert them into our original equation. So delta G standard state is minus 2222 minus 0.373 times 298. All the units will cancel appropriately, and I'm going to get my answer in kjoules per mole. And my final answer is minus 2111 kjoules per mole. A lot of work to do for one problem, but it's all good at the end of the day. That's going to be answer choice B. So for number 21, the best answer is B. Now let's move on to number 22. Entropy change for the reaction. Actually, we've already calculated that. We found that that was minus 373 joules per Kelvin. So for number 22, the credited answer is C, based on work we've already done. Okay, this reaction is going to be spontaneous. So it's not endergonic, we can get rid of D. It is not spontaneous because the entropy change is positive, because the entropy change is negative. The best answer is C, spontaneous, because the entropy change of the system plus the surroundings is positive, which means the delta S total is greater than 0, and that's the ultimate criteria for spontaneity. Do not confuse the total change in entropy with the change in entropy of the system. Our change in entropy of the system was negative, but the total entropy change was positive because when heat is released in this exothermic reaction, this heat results in more entropy in the universe. So for 23, the best answer is C. All right, so with number 24, we're going to go to an electrochemistry question. And we're looking at Cu2 plus 2 electrons yielding Cu metal. And so let's start with what we know. We have 2.64 grams of copper. I know that there are 63.55 grams of copper in 1 mole of copper. So notice grams of copper cancels. We want that to occur. I know that 1 mole of copper requires 2 moles of electrons. And I know that 1 mole of electrons requires 96,485 coulombs, a Faraday. I know that the current is 1.876 coulombs per second. And so now I finally have the units that I am required for the answer. And now I can just evaluate this huge fraction. So 2.64 times 2 times 96,485 divided by 63.55 divided by 1.876, and I get 4,273 seconds. 4,273 seconds. So if I look at my answer choices, A is clearly the best one from which to choose. 24 is A. Moving on to number 25. We know from the Nernst equation, actually I'm going to try to scroll this up a bit. We know from the Nernst equation that E of cell is equal to the E standard state of the cell, which we get from redox potentials, minus 0.0592 over N, the log of the concentration of products. In this case, that's going to be Fe 3 plus squared over the concentration of Fe 2 plus squared times the concentration of hydronium squared. And I'm going to increase the pH. If I increase the pH, I'm going to decrease the concentration of hydronium. This fraction becomes larger. I subtract a greater number from E cell. So E cell equals E cell standard state minus bigger number. That means that E cell must go down. Best answer is D. Now, E cell standard state is a normalized value. It will never change. So A and B can be immediately eliminated. So for number 25, the credited answer is D, must use the Nernst equation. There's really no other way to do it. Number 26, we have to balance the following redox equation. So this is a nice review of something we did relatively recently. We have Cr2O7 2 minus aqueous plus SN2 plus aqueous yields Cr3 plus aqueous plus SN4 plus. First thing we want to do is assign oxidation numbers. Chromium will be +6. I know that's +6 because oxygen is -2. -2 times 7 is -14. Which means these two need to be a +12. 12 divided by 2 is 6. And of course 10 is +2. Chromium is of course +3. And 10 over in products is +4. So let's look at the reduction. Cr2O7 2 minus. I need 2 chromiums to balance. I'm going to use water to balance the oxygens. Now I need 14 H pluses. And finally, I'm going to need 6 electrons. +8 charge, +6 charge, +6 charge. The 10 is much easier to handle. SN2 plus yields SN4 plus +2 electrons. Now I need a common, at least common multiple. I'm going to multiply this one by 1, and the bottom one will multiply by 3. So we get 14 H plus Cr2O7 2 minus plus 3SN2 plus yields 2Cr3 plus 7H2O plus 3SN4 plus. So we have a +18 and a +18. The question asks the smallest coefficient for dichromate, and that of course is 1. That is answer A. So number 26, the best answer is A. If you have 2 beakers and you have an aqueous solution of NaCl in beaker A and a nonpolar solution of liquid hexane in beaker B, they won't mix because one solution is polar and one is nonpolar. One has significant IMFs, that being the NaCl and water, ion dipoles, and one does not. They're just London dispersion forces. Number 27, the best answer is credited response D. Number 28 bothered a lot of you guys. It's really not all that bad. We simply need to know the rate of disappearance. And so we're going to look at the change in concentration of our reactant divided by the change in time. And so at 20 seconds, it was 0.480. At 80 seconds, it was 0.441. Now that's a change in molarity. And time, 80 seconds minus 20 seconds. So that's going to be 0.039 divided by 60 seconds. Of course, molarity in the top. So you already know that A and C are going to be wrong. So 0.039 divided by 60 is going to be 6.5 times 10 to the minus 4 molar per second. That is credited response A. Number 29, we want to determine the rate law. And so we know we first want to start with the rate is equal to the rate constant times the concentration of A to the X times the concentration of B to the Y. So let's look for X first. Let's look at two experiments where B does not change, 1 and 3. A doubles, and the rate does not change. Therefore, X must equal 0. So A is simply not a part of the rate. So A is wrong, and C is wrong, and D is wrong. The best answer is B for number 29. All right, let's do 30 through 32, and then I'll pause this particular podcast. If we look at this titration curve, first of all, realize that we're starting with an alkaline solution, so we can get rid of A. And we're starting with an alkaline solution that has a definite buffer region. There's a buffer region right here, so it's got to be a weak base. Also, if you look at the equivalence point, it is acidic. It's around 5, so you must be titrating a weak base with a strong acid. That is going to be answer D. Number 30, the answer is D. The equivalence point, that's going to be the X value where this pH really changes, and it's just below 20. And so the best answer is going to be B, 20 milliliters. And of course, in green, we're taking the first derivative of pH versus titrant volume. So number 32, the answer will be A. So 30, D, 31, B, 32, A. So I will pick up on question number 33 on the next screencast.